Let me start with something very simple. Something we often forget because we love science fiction more than reality. The universe does not care about us. It does not care about our dreams, our ambitions, or our desire to spread across the stars. Physics does not negotiate. Nature does not compromise. And this is exactly why the idea that humans can simply move to another planet and live there is, at least with everything we know today, essentially, impossible. We evolved here on Earth. Every cell in your body, every chemical reaction that keeps you alive, every beat of your heart is tuned to the very specific conditions of this planet. The gravity, the air pressure, the oxygen concentration, the magnetic field, the radiation shielding provided by our atmosphere, all of it works together like an extraordinarily delicate machine. Remove even one part and the machine begins to fail. Take gravity for example. People imagine living on Mars as if gravity were just a small inconvenience. But gravity is not a background detail. It is a fundamental force shaping your bones, your muscles, your blood flow, even how your brain functions. In microgravity or low gravity, bones lose calcium, muscles waste away, the heart weakens, and the immune system becomes confused. Astronauts who stay in space for months return physically damaged. And that's after constant exercise, medical monitoring, and a fast return to Earth. Mars has only about 38% of Earth's gravity. No one knows what decades of that would do to a human body, but all evidence suggests it wouldn't be kind. Then there's radiation. On Earth we are protected by a thick atmosphere and a powerful magnetic field. These shield us from cosmic rays and solar radiation that would otherwise tear through our DNA like bullets. Mars has almost no magnetic field and a very thin atmosphere. Radiation there is not a minor problem. It's a constant, unavoidable assault on your cells. Over time, it increases cancer risk, damages the nervous system, and accelerates aging. You can try to hide underground, build thick walls, invent clever shielding, but now you're not living on another planet. You're surviving inside a bunker, desperately recreating Earth while pretending you've escaped it. And let's talk about air. Humans are astonishingly fragile when it comes to breathing. The exact mix of gases matters. Too little oxygen, you die. Too much, your lungs are damaged. Mars's atmosphere is mostly carbon dioxide with a surface pressure so low that exposed human blood would literally boil. Without a suit or a sealed habitat, you don't last minutes, you last seconds. So, every breath you take off Earth must be manufactured, monitored, recycled, and protected from failure. One small leak, one mechanical error, and the environment instantly wins. Water, food, energy. These are not minor engineering challenges. They are massive, ongoing struggles against entropy. On Earth, ecosystems recycle everything naturally. Plants produce oxygen. Bacteria break down waste. Oceans and forests regulate climate. On another planet, you must artificially replicate systems that took billions of years to evolve. Closed ecosystems are notoriously unstable. We've tried building them on Earth, and they fail. Even here, under ideal conditions with gravity, shielding, and immediate rescue available. People often say, but technology will solve it. That's a comforting phrase, but it's not a scientific argument. Technology does not remove physical laws. It only works within them. You can't engineer away radiation. You can't invent gravity. You can't redesign the human organism overnight to survive in hostile environments. Every solution adds complexity. And complexity means more ways to fail. Space is unforgiving. There are no second chances, no nearby hospitals, no emergency oxygen deliveries. And then, their psychology. Humans are not machines. Isolation, confinement, artificial light, a dead landscape. Outside the window, these things slowly erode the mind. Even in Antarctica, on Earth, with fresh air and rescue possible, people struggle on another planet millions of kilometers away with no hope of escape. The psychological pressure becomes a serious threat to survival. So, when people say humans will live on another planet, I ask, live how? Breathing recycled air, hiding from radiation, eating manufactured food, confined inside metal shells, dependent on machines every second of your existence. That's not living on another planet. That's carrying Earth on your back and hoping it never breaks. The truth is not that humans are weak. The truth is that Earth is extraordinarily special. It is not just a rock we happen to live on. It is a finely balanced system perfectly suited to us. We are not cosmic nomads by nature. We are products of this planet. And until we fundamentally change what it means to be human or discover a world identical to Earth, the idea of humans truly living on another planet remains not just difficult but effectively impossible. And that's not pessimism. That's physics. And if that sounds harsh, it's only because we've trained ourselves to confuse hope with evidence. Because hope feels good and physics does not care how we feel. And the deeper you examine the problem, the more obvious it becomes. That space is not an extension of Earth, but its complete opposite. A vacuum that actively works to dismantle life rather than support it. And every so-called plan for colonization quietly assumes a level of control over nature that humanity has never demonstrated, because when you say humans will adapt, what you really mean is that machines will constantly fight nature on our behalf. And machines fail. They wear out. They break in ways you didn't predict. And in space, there is no margin for error. No slow failure mode where you can improvise and recover, because every system keeping you alive is operating at the edge of catastrophe. And this becomes even more serious when you scale from a handful of astronauts to entire populations, because redundancy works for 6 people in a spacecraft, but not for thousands, trying to survive for generations. And people like to imagine children being born on Mars as if biology were negotiable, ignoring that pregnancy, fetal, development, bone growth, and brain. Formation all depend on gravity, radiation shielding, and stable environments that simply do not exist there. And we have absolutely no data showing that a human can be born, grow, and live a healthy life off Earth, which means colonization is not an engineering project, but a biological experiment with human lives as test subjects. And that alone should give us pause, because the universe has a long history of killing things that make assumptions. And even if you somehow solve radiation with absurdly thick shielding and solve gravity with rotating habitats and solved air with perfect recycling systems, you are still left with the fundamental issue of energy, because every artificial solution requires power, constant power, uninterrupted power. And on Earth, energy failures are inconveniences, but in space, an energy failure is an extinction event. And solar power weakens with distance. Nuclear power introduces heat and waste. Problems, and all of it, must be maintained by humans who themselves are slowly being degraded by the environment they are trying to control. And people underestimate how quickly a closed system accumulates small errors. A tiny imbalance in oxygen here, a trace contaminant there, a microbial shift you didn't anticipate. And over time, these tiny deviations grow until the system collapses, because nature does not sit still. That evolves, and it always finds the weakest point. And the irony is that the more complex your life support system becomes, the more fragile it becomes, because simplicity survives. Chaos and complexity does not. And Earth works not because it is simple, but because it is vast, redundant, and self-seized, erecting on a scale no human technology can replicate. And that's why we can damage it for centuries and still survive. But a Mars habitat damaged for 10 minutes could end everyone inside. And this leads to a deeper misconception. The idea that space colonization is an escape plan. That if Earth fails, we can simply move on. When, in reality, the only reason we can even consider leaving Earth is because Earth already solved every hard problem for us. And without it, we are infants, wandering into a lethal environment, wearing fragile life support backpacks. And the universe is under no obligation to keep those backpacks functioning. And so when people say humans are destined to become a multi-planeted species, I ask, where this destiny is written, because it's not written in the laws of physics, it's not written in biology, and it's certainly not written in our engineering track record, which shows that even on Earth, our most advanced systems require constant maintenance, constant resources, and constant oversight. And space removes all of that safety net, stretching supply lines across millions of kilometers and turning every bolt, seal, and software update into a potential failure point. And even communication itself becomes delayed, making real-time problem solving impossible. So mistakes compound before help can even arrive. And this is why. Exploration is realistic, but settlement is not. Because visiting a hostile environment briefly is fundamentally different from trying to exist within it indefinitely, and confusion between. Those two ideas is where science fiction quietly replaces science and none of. This means humanity should stop dreaming or exploring or pushing boundaries. It means we should understand what those boundaries actually are, because the most dangerous thing is not admitting limits, but pretending they don't exist. And if there is a lesson written across every failed space habitat concept, it is this: Earth is not replaceable. It is not optional. And it is not merely the first planet we happen to try. It is the only environment we know that does not require constant resistance against death. And until humans can rewrite biology itself, not tweak it, but fundamentally alter it, the idea of humans truly living on another planet remains a story we tell ourselves to feel less fragile in a very large and indifferent universe, and recognizing that fragility is not weakness, it is honesty, and honesty is where real science begins. And once you accept that reality, something interesting happens, because the conversation shifts from fantasy to responsibility, from asking how fast we can leave Earth to asking how well we actually understand it. And that is where the real scientific challenge lies, because Earth is not easy mode. It only feels easy because we evolved inside its rules. But even here we struggle to manage climate, ecosystems, energy, and resources without unintended consequences, which should immediately tell us something important: that if we cannot maintain stability on a planet that naturally supports life, the idea that we can manufacture stability on a planet that actively resists it is deeply questionable. And this resistance is not dramatic or cinematic. It is subtle and relentless. It appears as dust clogging, machinery, radiation slowly corrupting, electronics, materials becoming brittle, under temperature extremes, microbes, mutating in closed environments, human bodies quietly changing in ways that only become obvious after it is too late. And all of this happens while public imagination focuses on rockets and landings, because launching something into space is exciting and visible. But keeping something alive there indefinitely is boring, repetitive, and brutally unforgiving. And history shows that it is the boring failures that end civilizations, not the dramatic ones. And when people argue that humans have always overcome hostile environments, they forget a crucial detail: that every hostile environment that humans ever conquered was still Earth, still under Earth's gravity, still protected by Earth's magnetic field, still connected to Earth's biosphere. And there is no historical precedent for a species leaving its entire life support system behind. And expecting technology to replace it perfectly, because technology does not evolve on its own. It must be designed, powered, repaired, and understood. And every generation born away from Earth would inherit not freedom, but dependency. Dependency on machines they did not build, systems they cannot allow to fail, and environments that offer no forgiveness. And that raises an uncomfortable ethical question whether creating such a future is progress or simply a more elaborate form of captivity. Because a colony that cannot survive without constant technological intervention is not a new world. It is a fragile extension cord stretched across space. And the longer that cord becomes, the more inevitable its failure becomes. And even if you imagine a perfectly functioning colony for a few decades, the time scale of human survival is not decades. It is centuries and millennia. And systems designed by one generation must survive the mistakes, neglect, and ignorance of future generations, which is something we already fail at. Earth, where abandoned infrastructure collapses within years, not centuries, and space does not slow decay, it accelerates it. And this leads to a deeper misunderstanding about intelligence itself. Because intelligence does not mean domination over nature. It means understanding limits and operating within them. And pretending those limits do not exist is not optimism. It is arrogance. And the universe has a consistent response to arrogance, which is silence followed by consequences. And when you strip away the slogans and inspirational speeches, what remains is the simple truth that humans are not designed for space, not emotionally, not biologically, not socially, and not evolutionarily. And redesigning ourselves to fit space would require changes so profound that the result might no longer be meaningfully human. And at that point, the question is no longer whether humans can live on another planet, but whether something descended from humans might. And that distinction matters because it reframes space colonization not as expansion, but as transformation. And transformation carries costs we rarely acknowledge, including the loss of what makes Earth life familiar, spontaneous and resilient. And perhaps the most revealing part of this entire discussion is how quickly people jump to space as a solution while neglecting the extraordinary improbability of Earth itself. Because Earth is not merely one planet. Among many, it is a statistical miracle, a convergence of conditions so precise that even small deviations would have rendered it lifeless. And yet, instead of treating that miracle as something to protect, we talk about abandoning it as if it were replaceable, as if planets were interchangeable real estate rather than deeply integrated systems. And this mindset is dangerous, not because it encourages exploration, but because it encourages neglect. Because if you believe escape is possible, preservation feels optional. And physics does not reward optional thinking. And so the real value of space. Exploration is not as a destination for settlement, but as a mirror. Something that shows us how hostile the universe is, and by contrast, how precious and rare our home truly is. Because the more we learn about space, the more obvious it becomes that Earth is not holding us back. It is holding us together. And the dream of living on another planet often reveals more about our discomfort with responsibility than our readiness for the cosmos. And perhaps the most scientific conclusion we can draw is not that humanity is destined to spread across the stars, but that intelligence carries the burden of stewardship, the obligation to care for the only environment that allows it to exist in the first place. And until we can demonstrate long-term stability, cooperation, and sustainability on Earth, the idea that we will achieve it somewhere far harsher is not visionary. It is contradictory. And recognizing that contradiction is not surrender, it is clarity. Because science is not about telling comforting stories. It is about confronting uncomfortable realities. And the uncomfortable reality is that Earth is not just our birthplace. It is our operating system. And without it, everything we call civilization collapses into a thin layer of machinery, fighting entropy 1 second at a time. And entropy always wins eventually.